Well, good morning. Time to do some homework. 70 is a question that gains increasingly importance next year, at least in the standards in Tennessee. It's not something I ever push like I ought to, but it's about transformations and transformation of equation without having a graph. It says apply the following transformations in order. All right, so the graph is y equals x to the 1/3 power. You don't have to graph it, but this is the first thing. It's given. Y equals x to the 1/3. That's given. Just going to do this as a two-step proof kind of deal, so see what's going on. Second thing is we shift 2 units right. So a shift 2 units right is something that happens with x, and it's always opposite of what you think. But if we're going to shift 2 units right, it works opposite of how you feel about it. You're actually going to take away 2 from x, and that handles the shift right 2. The next thing is we reflect on the x-axis. Now, reflection on the x-axis would take a positive y value and make it negative. And so to do that, we just insert a negative in front of the entire equation that we've written. Now we're going to translate it up 4. Translating up 4 is just as simple as adding 4 to it. And now we're going to compress it by a factor of 2/3. So that's it actually doesn't say what kind of compression, but presumably it's a vertical compression. So compress by 2/3. And you just simply insert a 2/3 in front of it, and you'll be done. It's pretty easy stuff, actually. It's just translations. Notice it says this: a single final answer is wrong. Don't be that kid. So that was 70. All right, 71, 72, state the domain and range for the graphs below, then write their equations. That sure looks like a parabola to me. It sure does. It's got a vertex here about 1, 1. I'm looking at it right. I guess I'll do the domain and range first because I have a tendency to forget about them. We have been looking at quadratics in my class since maybe end of September. This thing runs forever left, runs forever right. That's if you like interval notation. If you're a fan of the set builder notation, all values of x such that x is an element of the real. Range is the low y value up, so it would be from 1 with a bracket, because that's an actual point that exists, all the way to infinity. Or again, if you like your set builder notation, which a lot of people do, because they just don't get intervals, all values of y such that y is greater than or equal to 1. It's not bad. It's not bad at all. All right, now for the actual equation. This is a quadratic, so when I start this off, I think y equals a times x minus h all squared plus a k. I get h and k from my vertex, and I just plug those in. And I'm really close to being done with the equation at that point in time. I just have to know this scale factor, or this initial slope. I don't know how your teacher teaches it, but that's all I got to know. And that's what this little guy's for. That little guy gives me an x and a y. And if I plug x and y in, I'll have a single variable equation. So 3 is a times 0 minus a 1 squared plus a 1. You do a little math. A negative 1 squared is 1. So just 1a plus a 1. You take away the 1, you get a 2. And your a value is 2. So here's your equation. Y is twice x minus 1 squared plus 1. 72 is a transformation of the square root function. This is the arm. So I'm thinking y is a square roots of x minus h plus k. That's all I'm thinking about. It's just an arm. You're told that somewhere on this thing is the 0.5, negative 5. And you can figure this point out right here pretty easy. That's 1, negative 1. And that's where I get my h and my k. See, arms don't have a vertex. They kind of do if you drew the entire parabola. If you drew the negative square root, you'd see that. Or in this case, sorry, the positive square root. But anyways, there's your h and k. So let's start with y equals a roots of x minus h plus k, and we'll plug in what we got. Everywhere I see an h, I'm a 1. Everywhere I see a k, I'm a negative 1. Y is a times the root of x minus 1 minus 1. And then I can do the same thing I did on 71. I have an x and a y that I can just plug on in. So negative 5 is a times the root of 5 minus 1 minus 1. You do 5 minus 1, you get a 4, right? The root of 4 is a 2, so 2a minus 1. You add 1 to both sides. Negative 4 is 2a, and my a value is negative 2. So I get this nice little equation that y is negative 2 roots, going back here now, x minus 1, and then take away 1. And this makes sense because the thing opened down. It should have a negative symbol in front of it, shouldn't it? It should. All right, domain and range. I hate that I'm running into this thing, so I showed a lot of work there. Part of me as a teacher doesn't like showing a lot of work because it just takes up a lot of room and kids think it's tedious, but I got to show all the steps because, you know, I got kids who don't know what 5 minus 1 is. Why the state of Tennessee makes you take Algebra 2 is beyond me. But it is what it is, right? And that's something. As soon as you can learn to accept it is what it is, you'll be a lot happier. Talk about my domain here. This thing started at 1 and it moves right forever. And 1 is a valid thing that this thing can handle. Because if you plugged in a 1, you'd be taking the square root of 0, which exists at 0, contrary to what some people believe. That's as an interval. If you like set builder notation, all values of x such that x is greater than or equal to 1. Range on this thing, the first y value that I encounter is negative 1, and then it falls for all eternity. So the range is negative 1 to negative infinity. Or again, if you love your set builder notation, if you intend on doing something that's going to require a lot of math, learn your notations. Y is less than or equal to negative 1. If your goal is just to get through college algebra, at least know what they are. Know how to read them. All right, these are the ones I actually like. I don't know why I like these, but I do. Solving radical equations. They're not necessarily hard. I do wish I would have given more of these in exponential form, but I didn't. I'm actually, as I do these assignments, I'm actually going to rewrite everything with exponents because as you move forward, the exponents are a bigger deal than a radical symbol. So I'm going to move forward. Radical solutions do also want you to check your work. All right, so we're going to move a 2 over. I'm going to rewrite this as negative 2x plus 3 to the 1/2 power. And when I add 2 to both sides, I'll have a 12. Now, the reciprocal of a half is to square. So I'll square the left, and if I do such a thing, I need to square the right. When we use that product that talks about an exponent raised to an exponent, we multiply these guys out. And a half times 2 is 1. And 12 squared is 144. I am going to subtract 3. Negative 2x is 141. Then I'm going to divide by negative 2. I get that x is negative 141 seconds. And it does talk about checking. So I'm going to check, and I'm not going to write out how I'm doing it, but I'm just going to take my little negative 141 seconds, and I'm going to push it in right there. And I'm going to type the original function using exponent notation, negative 2x plus 3 to the 1/2 power. Oops, I didn't store that to x, did I? Let's do that again. Negative 141 over 2, store it to x. Type in the original function, negative 2x plus 3, rooftop to the 1/2 power, and a minus 2. And what I hope is, once I press enter, a 10 shows up. And it did. So it's a good answer. It's not extraneous. 74. Negative 4, x to the 1/2 is now a negative 14 because I added 6. Hope you get that. Divide by the negative 4 and x to the 1/2 would be 7 over 2 when everything is said and done, because 14 over 4 is 7 over 2. The opposite again of the half power is the square power, and I don't even need TI-84 for this one. This gives me that x is 49/4, because if you square 7, you get 49, you square 2, you get 4. I don't foresee that being a problem, but, check it. 49 over 4, store it to x. So negative 4x, I don't know why I use parentheses there. Well, I know why I use parentheses there. X to the 1/2 minus 6. Press enter and pray to God you get a 20. And, sorry, negative 20, you did. It's a good answer. 75. We got a cube root here. Negative 4x plus 10 to the 1/3 power is 10. Divide out that negative 4. X plus 10 to the 1/3 power is negative 5/2. How do you counteract the 1/3 power? By cubing. This will free up x plus 10 because, again, we multiply these two exponents together. If I take a negative 5 and I cube it, I get negative 125. If I take a 2 and I cube it, I get 8. And the next step here is to subtract 10. So I'd be taking away 80. I should get negative 205 over 8, which I don't feel reduces. I don't feel that it does. All right, check my work. I got negatives. Take a negative 205 over an 8, store it to x, and then type in the original function. Negative 4x plus a 10, rooftop to the 1 over a 3, plus a 3, and hope I get a 13. And I did. 76. X minus 5 to the 5/3 minus 73 is 170. So I'm going to add 73 to both sides, and I feel like that gives me 243. Looks like I spent some time making that one. The opposite of the 5/3 power is its reciprocal, which is 3/5. The answer to that should be 27. But I'm pretty sleepy this morning. So 243 to the 3/5, I feel like the answer is 27. And I was right. This is 27. Now, something I talked about in class here, this is an odd root. It has one answer. All right? So I'm okay with what the TI-84 told me. I am. I haven't actually used a root yet. I've been squaring, and I haven't done a root. I'm going to add 5 to both sides, and my x value is 32. And again, I check. Take 32, store it to x, type in the original equation. It doesn't take that long to check your work. And what I hope I get back is 170. By the way, that's a great standardized test skill. If you're taking a multiple choice test, plug in answers. 170. Awesome. Ain't made a mistake yet. All right, 77. We got a half power. The opposite of half power has to be a square. This is typically when the extraneous answers show up, when you're dealing with the even roots. In fact, I think that's always true. I don't want to make a statement that it is, but I'm pretty confident that it's always true when you're doing even powers. It should be true. But when you square a half power, you get what's inside. And then we're going to add 11. We're going to get 36. And then we're going to multiply by a 3. And I feel like that gives me 108. I only have one answer. The odds of it being extraneous or not working are actually kind of slim. But check it. It's an easy skill to do. Got a 5. Good to go. And I got more things to do today, and I'm spending the time checking it, so you can too. All right, so this is written out as a square root. I'm going to go ahead and change it to an exponent because I really want you to understand exponents. I really, really do want you to understand exponents. The opposite of the half power is squaring. And that's going to free up x squared plus 4. To do the right-hand side, I wish most of you were in this position where you didn't have to actually write it out twice, but you do. Write it out twice and FOIL. I'm not going to show all the work of foiling, but I'm going to get x squared plus 10x plus 25 when I do. Now I got a quadratic, man. A freshman is supposed to know how to handle this situation. This actually is not a quadratic. I'm sorry. Those cancel. They're in perfect balance. We'll take our numbers to the left. That'll give me a negative 21 as 10x. And so my x value is negative 21 over 10. And I'm going to check it. That's what I'm going to do. Take a negative 21 over 10, or negative 21 tenths, store it to x. Let's see, it was x to the second plus 4 rooftop to the 1/2 power. And I got 2.9. Okay, well, I've still got to evaluate the right-hand side, which is x plus 5. And they match. Good. Probably should have left more room for 80. 79, probably enough room. 79 is not intimidating. It's not. I know some kids might be intimidated by it because there's a radical on both sides. Big friggin' whoop, right? The opposite of the third power is the cubic power. So we just cube both sides. And that'll free up 12x minus 5 equal to 8x plus 15. X is on one side, numbers on the other. Same old thing you've been doing for half your life. Should get 4x is 20, assuming I can read my own handwriting. And I'll have an x value of 5. So I'm just a little curious. This is something that works out nice. That'd be 55. The numbers match. If you put a 5 here, you get 60 minus 5 is 55. It's asking you to take the cubic root of 55. If you plug a 5 in here, 8 times 5 is 40. So I have no idea what the cubic root of 55 is, but I know they're both the same. The left is the right. This is also way too easy. Why am I doing this? Well, I take that back. This one's got some more steps. We got 2x plus 3 to the 1/2 power. And what I'm going to do is I'm going to shift all my numbers right. I don't know why I opened up a radical. Didn't mean to. 3x plus 3 to the 1/2 power plus a 1. So what you do is you isolate a radical, and then you fix one of them. The opposite of the 1/2 power is the square, and if you square the left, you had best square the right. This will free up a 2x plus 3, and I'm going to shift my work over here because I'm going to need the space. Now I'm going to write this thing twice. And now I'm going to FOIL. All right, so this is kind of interesting. You know, what is 3x plus 3 times 3x plus 3 when they're both to the 1/2 power? Well, you have a rule that says x to the a times x to the b is x to the a plus b. So if I add a 1/2 and a 1/2, I get 1. So when you multiply a 1/2 power by another 1/2 power and they're identical, you just get what's inside. And distribute to the 1, so plus 3x plus 3 to the 1/2 power. Let's see here. I got to do that again. Plus another 3x plus 3 to the 1/2 power. And then lastly, plus a 1. So now I've got two 3x plus 3's to the 1/2 power on the right. And I'm going to shift everything else left. So 2x minus 3x is a negative x. 3 minus 3 is nothing, minus the 1. I shifted things around. That's all I did. Now I got to fix this half power. You could divide by 2, but I'm not going to. I'm going to square the right, which means I square the left. Now if I take x minus 1 and I write it twice and I FOIL it, I ought to get x squared plus 2x plus 1. I ought to. I feel pretty good about it. If I square the right, 2 squared is 4. If I square this half power, I get the contents of the interior, 3x plus 3. Leave it wrapped. Good news is we're getting close to being done. Distributed by 4, and it's a quadratic, so everything on one side set equal to 0. What's amazing is that when I made this problem up, I did it so that I would come up with something that factors. That is amazing. I don't even remember making this problem up, but I did it around 17, 18. Did I actually make something that factors? No, I didn't. Here I am. Yeah, I did. This factors as x plus 11 and x minus 1. Zero product property kicks in, x is negative 11 or x is 1. And now it's time to check. All right. One of these answers might be extraneous. They both might be extraneous. Don't know. Take a negative 11, store it to x. The right-hand side is the root of 2x plus 3 and then plus a 3. Non-real. See where it says non-real? This thing is extraneous. All right, let's try this again. Take a 1, store it to x. The right-hand side is the root of 2x plus 3, so the right-hand side generates this funky-looking number 5.236. Sorry, left-hand side. Type in the right-hand side, root 3x plus 3, and then plus a 4. They don't match, do they? Isn't that crazy? All that math, they don't match. Phooey. Also extraneous. Both those answers are extraneous. Isn't that just weird? And hey, I just finished the homework packet. Sweet. If I can do it, you can do it.